In this video, we'll talk about batteries. I already made a video on this topic, but I focus more on 3.7 volt batteries. Now, I'll talk about 1.5 and 1.2 volt batteries, which have been a topic of debate. Some people say that 1.2 volt batteries work fine, but that's not entirely true. If a device uses two batteries in series, in theory, that adds up to 3 volts in reality. Two new batteries can reach 1.6 volts each, meaning a total of 3.2 volts in series. And when they're drained, that value is very relative. I've seen temperature sensor transmitters working fine with 1.1 volts per battery. So it depends on the device. Rechargeable 1.2 volt batteries can be charged any value between 1.36 volts and a maximum of 1.41 volts if a device requires 3 volts. Two of these batteries connected in series would only give us 2.74 volts. If the device has a display, it won't show 100%, even when fully charged. Normally, their float voltage is around 1.25 volts. 2 in series will be 2.5 volts. So even with enough charge, they might be detected as low battery. In conclusion, depending on the device, we may or may not be able to use 1.2 volt rechargeable batteries. But I also want to dedicate this video to 1.5 volt rechargeable batteries, which I wasn't familiar with. I don't know how long they've been available on the market, their operating voltage, etc. Any clarifications will be in the description and comments. So I bought 4 AAA rechargeable batteries to test them. This battery weighs 11 grams, a 1.2 volt rechargeable battery weighs 8 grams, and a regular battery weighs 12 grams, since I don't know the maximum charging voltage. I measured all the batteries and took the highest value as the maximum to avoid damaging them. That value was 1.637 volts. Any updates or changes to that value will be in the description or comments. Now I'm going to check the maximum current it can deliver instantly when short-circuited. I set the ammeter to the 20 amp range and took a quick measurement of less than a second to avoid damage. For 0.55 amps, pretty good. Now I proceed to charge it. This way, I make sure that 100% with a maximum voltage of 1.637 volts. The capacity isn't specified, but we can estimate it using a 0.3 amp lamp to see how long it lasts. It lasts an hour and a half with 300 milliamps, so the battery has a capacity of 450 milliamp hours. I didn't want to end the video without using this new 1.5 volt rechargeable battery to install it in a wall clock I have near the power cable, which, when connected, delivers about 9.45 volts. I use that voltage to create this circuit. First, I add a diode in case I connect the voltage in reverse. Then, the L7805 voltage regulator, always with 2 capacitors, one of 330 nanofarads and another of 100 nanofarads. Next, a 1 kilo ohm resistor, so an LED indicator can show that it's powered on. After that, a diode to create a voltage drop, so the voltage divider, made of 2 4.7 kilo ohm resistors and a PC547 transistor, can work properly.
Then, a small 2.2 microfarad capacitor in our 1.5 volt rechargeable battery to connect it to the wall clock. If you only have 3.7 volt batteries, you can make the same circuit by placing the 3.7 volt battery between the diode and the transistor. However, the last capacitor should no longer be 2.2 microfarads but 47 microfarads. If you don't need to use the initial power circuit and only want to use the 3.7 volt battery to generate 1.5 volts, here's the simplified circuit. So now you know, don't confuse 1.2 volt rechargeable batteries with 1.5 volt ones.